In this video, we're looking at how to use the sine rule. We have seen that trigonometric ratios SOHCAHTOA works only for right-angled triangles. There are also some patterns that will work in any triangle. They are called the sine rule and the cosine rule. Now, in this lesson, we'll be looking at the sine rule. Let's look at a diagram. We have this triangle, and let's label it ABC. So we have triangle ABC. Now, opposite angle A is side A. Opposite angle B is side B. So we can say side AC is really side B. And side BC is really side A. And side AB is side C because it faces angle C. So that's by this labeling convention. Opposite the angle is the side. So we use same letter, in other words. So the sine rule, though, is that if we take the measure of side A, this length here, and divide it by the sine of the angle it faces, in this case sine of A, we will actually get the same value as if we were to take the measure of this side, which is considered side B, and divide it by the sine of the angle it faces, and we'll have the same value, okay? And if we were to take side C here and divide it by the sine of the angle it faces, we'll get the same value. So in other words, these ratios are all the same. Hence, we call this the sine rule. Now, we can use this formula when trying to find what? The side. It's easier to use this one. And when trying to find the angle, we simply upturn the rule or the equation that we have. So in trying to find the angle, it's easier to work with the angle on top. Trying to find a side, easier to work with the sides on top. Okay, now let us look at an example. Now, determine the value of the missing side, labeled A. Alright, can we use the sine rule? Of course we can. As we can see with this triangle, we have the missing side, or the side labeled as A that we don't know, faces the known angle. And then we have a known side facing a known angle. So in fact, what we're seeing here is this. Alright, we're seeing that we have A that we're trying to find, we do not know what it is, but the angle it faces we do know. So in this case, we have a half pair, and we're going to equate it to a full pair. So we can actually label the triangle, as a matter of fact. Let's label. So if that's side A, side we're trying to find, let's call it angle it faces, angle A. And the side that we're given, let's call that B, and the angle it faces, angle B. So we're basically going to take this portion of the equation and use that to solve for the unknown. So what we're going to do now is replace the unknowns, or should I say replace the variables with the known values. And once we sub those values in, this is what we get. Okay, so remember angle A is actually 74, angle B is actually 49 degrees. And so now what we need to do is to multiply both sides by sine 74. Why is that? Because if I multiply this side by sine of 74 and multiply this side as well by sine of 74, what will happen here? This allows me to cancel off the numerator here of sine 74 with the denominator of sine 74, allowing me to isolate A. So now all I got to do is work out this side. 12 over sine 49 multiplied by sine 74. So let's see what we have there. So multiplying both sides by sine 74, we get A equals this result. And putting this in our calculator, we end up with the result of A equals 15.3 centimeters to 1 decimal place. Okay? Now remember, this is actually degrees, but when you input it in calculator, just leave it as sine 49 and sine 74. Let's look at another example. Now, if you look at this, we have a half pair, unknown side, but known angle. That's a full pair, known side, known angle. So we're going to use this. So in fact, let's label, utilizing the letters in the formula. So I'm going to label this as A, the same side that we're trying to find, and the angle it faces is angle A. So even though we're trying to find side Y, we can just relabel it as A. And the angle and side that we're given, we use B. So side B faces an angle B. And then we set up our equation, substitute our values in, and then we're going to multiply both sides by sine of 101 degrees, leaving us with A on this side, since we multiply both sides by the sine of 101, and we'll have this side be multiplied by sine 101 as well. Inputting this in our calculator, we'll get the solution of A equals 12.9 centimeters to 1 decimal place. All right, now let's look at the next example. In this case, we're trying to find the missing angle theta. But notice still that we have what? Facing the angle that is unknown is a known side. But this is a half pair because one end is not known, in this case the angle, but the other end, the side, is known. Look at the other pair, we have a known side facing a known angle. So we can label these. The angle we're trying to find, we can label that as angle A, and the side facing it as side A, and the other pair as our B. So angle B, side B. Now we can put down the formula. Remember, since we're trying to find the angle, we put the angle on top. Now in this case, let us substitute our values in first off. Now once we get our values substituted based on what we have for the labeling, you can check it out. We're going to try to get rid of what first? Remember, our goal is to find the angle A, which is really theta. So I'm going to get rid of the 16 first by multiplying both sides by 16. Multiplying this side by 16, remove 16, leaving us with sine A on that side. Then multiply this side by sine. No, let's go with that. Multiply this side by 16, multiply this side by 16. So both sides get multiplied by 16. Why? So we can remove 16 from the denominator because our goal is to isolate A. Let's do that first. And so once we have this, now we're going to try to get rid of the what? Well, first of all, we can actually work this out because every value over here is known. The B that was unknown becomes known, as in we substitute B with 76. We already have 18. We carry across 16 to multiplication. So this can be inputted in our calculator, right? And that will give us a value of 0.862, etc. So now we need to find the inverse of this value to give us A. Inverse of what? Well, sine inverse of this value. Since we have sine of A, to find A itself, we need to find sine inverse of this value. So sine inverse of this value will actually give us A being 59.6 degrees to 3 significant figures, or we can say to 1 decimal place. Sure. Now let's look at this exam question. Here we have triangle ABC, correct? And we're asked to find the length of side AB. But notice facing side AB, we have what? Angle C of 24 degrees. So side AB can be considered side C as well, right? But we can actually just use AB in place of C. We know it's still C that we're looking at because C faces angle C. So we're going to put this side AB over as a sine of 24 degrees. All right, let's put that in. All right, AB, which is really C, facing angle C, over the sine of 24 degrees, or over sine C. I'm going to equate that now to what we're given. We're given what? Which side are we given? We're given this 17 centimeters. I'm going to divide that by the sine of the angle it faces, sine of 95. So let's put that in. And then we're going to multiply both sides by what? The sine of 24. Multiplying this side by sine of 24. It will cancel out sine 24 in the denominator, leaving us with AB on that side, and then we multiply this side as well by sine 24. And so calculating the right hand side, we'll be left with what? AB equals the calculator value of 6.9409, etc. But let's say we want 3 sig fig. The first sig fig is 6, second is 9, the third is 4. Do we add 1 to 4 or leave it as 4? Yes, based on the next digit. The next digit is actually less than 5, and so we'll leave it the 4 as 4. So the answer is 6.94 to 3 significant figures. AB equals 6.94 centimeters. All right, thank you. Remember to subscribe, like, and share the video with someone that you know that needs the help. All the best in your exam. So, in summary, we have learned another rule of trigonometry, the sine rule. We have used it to calculate missing angles and sides in a triangle. We use it when we are dealing with 2 pairs of angles and sides, which includes either one unknown side or one unknown angle.